All right. Well, we are live. Good afternoon, good evening, good morning to everybody and anywhere. How are you?
Hi, Josh. I'm good.
Hey, buddy. Good. Yeah, John, I'm so glad you could be here today. This is actually a bit of a later stream. I appreciate that you're joining me. It occurs to me it's Friday afternoon. You're 2 hours ahead, which means it's 3:30 in the afternoon for you. You could have just
Yes.
gone home.
Yes.
No, you decided I'm gonna well, I mean, you might already
Well, I am home, but I could have gone out.
Yeah, yeah, exactly. Like the mafia. There's just when you think you're out, they pull you back in. So yeah, I'm really grateful for that, and thanks for joining me. And then to all of
Happy
you
to
who
be
are
here.
joining as well, cheers. Yeah, to all of you who are joining as well, I appreciate that you're joining us. Good many people that watch the show are in. Statistically, given where I live in the world, in California, in the west coast of the United States, a good many people are east of me. and indeed most people. So most people that watch tend to watch later in the day. So thanks to those of you who are joining. I appreciate it. Today, John, can you tell us about yourself? Like, who are you? What do you do? That kind of thing.
Sure. I'm a staff engineer at Grubhub on the platform engineering team, and I've been there about 7 years now. And I've had a lot of different roles at Grubhub throughout the years, but the past few years I've been on the platform engineering team. We're going to talk a lot about that, I'm sure. And then some of the other things that I do, though, I'm one of the maintainers on the KT-lint Gradle project, which is the most popular Gradle plugin for linting Kotlin code. And I also organize the Chicago Kotlin user group.
Wow,
got a few different things going on.
So you're really just a slacker. Is that what you're saying? Like, just...
I also have 2 kids.
Okay, yeah, wow, that's incredible. I mean, all those things, any of those things are interesting, and I suppose we could spend the whole hour and a half, whatever, talking about any one of them. But we'll just try and cover them in turn. Hello, Pritam. Hello, welcome to the show. We've got people still chiming in. It's getting on in the day in some of these places. What time is it in India? I mean, it's got to be early morning, right? So yeah, I appreciate everybody joining. So okay, you work on platform engineering.
Yes.
But I told the nice people that you're going to come talk to us about Spring and Kotlin and all that. So what gives? What's the difference there? What am I missing?
So yeah, in the industry, platform engineering is kind of this field I think that's taken off a lot the past couple of years. And we've had a platform engineering team for at least like 6 years. I think we've been calling it the platform engineering team. But the scope of our platform engineering team is a little bit more broad than I think what a lot of the other companies in the industry doing this kind of team encompasses. So we actually have 4 platform engineering teams. We have an infrastructure platform engineering team, which is kind of like your traditional platform engineering team.
Okay.
Then we have a front-end platform engineering team, a service platform engineering team, that's me, and we have a data platform engineering team. The service platform engineering team is not just me. I'm on that team.
Right.
There's a handful of us on that team.
Right.
So I'm on the service platform engineering side, and we've been a Java shop for a long time. So we have a strong commitment to the Java ecosystem, and our microservices platform is implemented in that. So that is part of our platform. We consider that part of our platform. And I can go into the history of how our platform has evolved over time if you want.
Right. Okay. So I appreciate the breakdown. We'll get into it. The reason I care about that is because you're a platform engineering senior staff at Grubhub. What is Grubhub?
Okay, so Grubhub, yes. Grubhub is a food ordering platform. So it's not just delivery. We actually started not doing delivery at all. That was something that we added later. So it's really just all-encompassing food ordering. So whether you are picking it up yourself, whether you're getting it delivered by one of our delivery drivers, or whether the restaurant is delivering it to you. In addition, we have other verticals as well. For example, we have stuff going on college campuses, sports stadiums, things like that. So it's a food ordering platform. And we operate in the U.S. And we are part of a kind of a larger group of corporations that operates worldwide.
Wow. Okay, that's cool. So I certainly know of it here. I live in the States, and it's very, 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 very popular here, right? How long has it been around? It's for like one of the OGs to me.
I think technically 2004 or 2005. It's been around. Yeah, it was the first real big one. Back before like managed delivery, what we call managed delivery, or like delivery was very popular. And then with the rise of like DoorDash and Uber Eats and those making the delivery aspect of food ordering more of a market, we went into that as well.
Aha. Okay, I didn't realize that. Okay, so you were like a just bring your restaurant to the internet thing. Yes. Before you were another way to get food delivered. So
right.
Oh, that's cool. Wow. And even getting food delivered is I'm sure if people asked some of your distinguished competition, they would say it's really hard, right? Even that just by itself is a whole thing. So for you to be able to do that well and maintain this entire other side of the business is phenomenal. You know, you must need force multipliers that a lot of people just don't necessarily think about, right? So
Yeah.
okay.
And don't get me wrong, the delivery part is the hardest part. That is very hard.
Yeah, that's cool. Okay, so talk to me. I mean, what is so you're when you talk about these services, you talk about service platform engineering, you talk about data, and you talked about what did you call it? Platform.
We have infrastructure and front end.
Infrastructure, yeah. So infrastructure, service, and data. You know, and so when I think of platform engineering, I think of like the Netflix model, right? Netflix said each team has full control over their own thing. The only exception to that is, for example, who's going to maintain the Cassandra stack, you know, or the cloud infrastructure. But everything else is basically use whatever stack. Anything above the VM, basically, you can do as you need.
Yeah, so that's a similar posture that we have. We in the past were a little bit more opinionated,
Okay.
and then over time we've loosened the opinions a little bit more. So we have a language agnostic platform. We use like an Envoy service mesh for all these services to communicate with each other. So really, we don't care what stack your service is running on, but we follow kind of the right at the platform level. But we follow kind of the golden path style like model where we say, sure, you can do whatever you want technically as long as it meets these certain criteria. But we do have something out of the box that is fully featured with all of these features that you can use and get running and productive right away. So you really have to have a strong case why you need something else. Part of the logic behind that was as we grew and started to acquire companies with other stacks, we wanted to be able to incorporate them into our stack without having to rewrite everything. So that's really the main driver for that, like being able to put like something from Python or Ruby or whatever else on our stack or on our platform. It's really so we don't have to rewrite a whole bunch of stuff that we acquired. So all of our first party stuff that we are writing is pretty much all Java microservices, and we have about 160 microservices.
Okay. Wow. Okay. So that brings up a great point. You have these other bits of infrastructure that you need to integrate. So those people, those folks working on that stuff, they get the wiki page with the 500 easy steps to production. Is that the idea that like they can do whatever they need to as long as they have these their thing matches a certain shape?
Yes, that's the idea, and that's still evolving. I mean, I'm not going to say we have that perfectly down either,
right.
But that's the direction we're going, and that's kind of like the posture we take as a platform engineering team.
And when you talk about platform, like technically infrastructure, are you what is? Can you talk about? Is that like Kubernetes? Is that? Oh, you said Envoy, so is it?
Yep.
Envoy.
We are using Envoy. We are so traditionally we're all AWS cloud. And I'm sorry, I saw a comment that maybe you can't hear me so well, so I'll lean into the mic a little more.
We can hear you. There's just a bit of a crackle, and it's
maybe I'm moving around too much.
I don't know.
Okay. So sorry about that. Yeah. So AWS cloud. So going back in
maybe go back a little bit. I don't know.
Back a little. Okay. Is that better? Okay.
Yeah.
Okay. So yes.
Whatever.
If I could take a step back a little bit and talk about the history, I think that might help explain it. In about 2014, Grubhub was the result of the merger of two companies, Grubhub and Seamless. So if you've been to New York, or if you were in New York in the 2010s, you probably have heard of Seamless. If not, then you probably haven't heard of it. But these were two very similar companies. Grubhub it was based in Chicago, Seamless in New York. Similar size, doing pretty much the same thing. They just merged.
Okay. Oh wow. Okay.
And so, but each one was running on basically like the original monolith architecture. And so instead of saying, let's convert all of the Seamless like business over to Grubhub, or all the Grubhub business over to Seamless, the decision was made back then. This is before my time, so I can't take credit for any of this. But let's build a microservices platform and then start replacing bits of the monoliths one at a time with microservices.
Nice. And then so it was the idea that both companies would then use the new microservice that replaced some bit of functionality in the old businesses?
Yes, yeah. And then it was just one stack, one microservices platform to handle everything.
So you did integration, but also renovation, right? Like you decided, well, you're going to have to do the work. You might as well just start, stand up a new one. Wow. So what was it like to move? Were they monoliths before at each?
Yeah, they were monoliths before. So we kind of like shaved off vertical slices, off of those monoliths and replaced them with microservices. It was a years-long process. It took a long time to finally decommission those old monoliths completely. It's one of those things where the last 10% of functionality took 90% of the time.
Naturally.
But we got it done. And so, but part of that process was, well, we want to go from running on our own racks to running in the public cloud. So AWS was chosen for that. But all the deployments and everything were basically, it's a bunch of custom Python scripts that we wrote right back then. Because Kubernetes, I mean, in 2014, Kubernetes was not really a thing so much. People were barely even doing Docker back then. And we did choose to use Docker. We were running Docker in production before most people were even messing around with Docker. So we did choose Docker, but we chose EC2, Amazon EC2. But now the time has passed. We are using Kubernetes. We're not fully rolled out on Kubernetes yet, but we are migrating towards that, replacing our orchestration with Kubernetes. Database-wise, we're running on Apache Cassandra for like most of our databases. We have exceptions to that, and we're using Elasticsearch in some places for search.
Nice.
And Java for the actual services themselves.
Nice. Okay. So these existing, since the great integration started in 2010, and since it completed more recently, you've onboarded new companies. Is that new systems that are written in these other languages?
Yes. So it's been a combination. The food delivery space throughout the years has been, there's been a ton of little tiny regional players, and then the bigger companies like us and our main competition, we tend to acquire those up to get like a better position in each city. So a lot of the smaller ones, when we acquire them, we just kind of, migrate their data into our stack, and then that's it, right? But some of the acquisitions have been like different kinds of verticals that we don't do, like the campus. Like I said, we have like college campus food ordering stuff. That was something that like we just didn't have support for anything like that in our stack, so it didn't make sense to try to move them into our stack. It made sense to integrate their stack to our stack. So that's where that comes from.
That is cool. So you've got you as an organization, you've become very agile enough to accommodate literally whole new systems just appearing at your doorstep.
Yes,
on a regular basis. Like wow, that's cool. That is super cool. Okay, so you talked about AWS. That's obviously a very common, very sensible default, especially 2014, right? And you were using and then at some point you moved to containers on AWS, and now you're moving to Kubernetes. Containers on Kubernetes, which is, I repeat myself. So good. So it sounds like the platform itself, the infrastructure, is pretty stock standard stuff, right? Anything like mainframey, any old COBOL?
No. Although we do still support faxes for the restaurants. Like we'll send you your order on a fax, but the restaurants want it. So
I know. This is what always blows my mind is just how much how many systems depend upon these. We think these things are gone, but you go into the back of a lot of restaurants, they're going to have a fax machine there. It just is the way. And you would think, well, surely everybody has a phone. That's not even true anymore. It's still not true. Not everybody has a phone.
Yeah.
Good stuff.
But then that brings us to like, why are we here to talk about Spring? Why am I here to talk about Spring Boot, right? We should get there. So, yeah, go ahead.
Well, I was going to say, hold on a second. what's the difference between the data platform engineering and the so what kind of data is that? Are we talking about Cassandra or Hadoop or what?
Okay, yeah. So the data platform engineering team is more like what a lot of people would call like the data lake. This is not production data. This is aggregating all of our data from our production systems into something that's able to be queried for whether it's training machine learning models or just generating reports for the business or things like that. So when we talk about Cassandra, like our production databases, that's that kind of falls under the infrastructure platform team.
Right. Okay, that makes sense. Okay, so now, and so you've got, when you talk about data, does each microservice have its own database and they're administered, maintained by this team, or is it that there's just one big thing and everybody uses that and connects to it or whatever?
So we have many Cassandra clusters, but it is not one-to-one. Every service has its own Cassandra cluster. Basically, each service has its own key space within the cluster, and then we have dozens of clusters. So it's not, so we can, if we have like a noisy neighbor, we have the flexibility to say this is going to go into a new cluster or its own cluster or something like that. So it's not just like one big Cassandra cluster.
Right.
But there are multiple services, just because it would be, if we had 160 different Cassandra clusters, the maintenance of that would be kind of overwhelming.
Yeah, of course. And plus Cassandra is great because it can be a durable, safe, reliable store of record, but it can also be highly optimized. It can be denormalized. So it's the view on the data, for a lot of different services that need a fast read model,
Yeah. So, but we don't have, we do have separation where every service has its own key space, so we don't have multiple services accessing like the same, tables, as, they don't share any data. There is a strict separation there. But Cassandra is really important because part of our platform that we built is hot multi-data center availability. And Cassandra is like the underpinning of that, because it's so easy to cluster it across data center. That's really what enables us to do it. So that's what we've been doing since 2014 is we are fully available in multiple AWS data centers at all times. And if there's ever a problem with one of them, we fail over our traffic to the other.
That's so cool. That's really hard to do too. That takes that's not one of those things where people just know how to do that out of the box. Cassandra enables it, but even there, it's when
there's a lot that goes into it, and so that's one of the big things that our platform provides is taking away the complexity of that, because we give you stuff out of the box that is set up to do it correctly, and you don't have to worry about it so much when you're writing your service.
Okay, good. Okay, so already we've got some interesting dimensions here. People are using containers. They're on Kubernetes. They're talking to a database that is dollars to donuts going to be Cassandra. What does that mean for the developer writing code these days on the JVM? Like they're using this, for example.
Well, so going back to that history, remember I said we kind of were the result of two companies, and so we were kind of dual headquartered after that. We had the old Seamless office in New York and the main headquarters in Chicago, and we had development teams in both. And there was just kind of like a cultural thing back then. Now our culture has gotten together a lot closer lately, but in the beginning it was a little bit more separate. You have a question?
Yeah, is the schism, which I know must be there, does it have anything to do with the differing definitions of pizza? Now,
well, listen, we are a food company, and these debates rage very hot at our organization. So, yeah.
Oh, okay.
Yes.
Bit of a difference.
So there was just kind of a tendency in one of the offices to use Drop Wizard. Remember, this is 2014, so Drop Wizard was a very kind of popular thing that was supposed to be, a simpler way of doing things than Spring, right? And then the other office had a tendency towards Spring because most of the developers had done Spring before. So when we started building our runtime platform, so this is our actual Java library, right? We're going to ship a Java library to all the developers that makes it easy for them to interact with our overall platform.
Uh-huh.
We call this library roux. Think like when you're cooking a sauce, what do you start with? Roux.
Oh,
So we built this library and we supported both. If you want to do Spring, that's okay. If you want to do Drop Wizard, that's okay. We were going to support both.
okay.
And so, and originally, even like those two flavors of our framework kind of were developed separately. But over time, we brought it together, put it under one banner, and we just kind of fully support it from the service platform team perspective.
Nice.
So that being said, nowadays, when I say Drop Wizard, it's not even Drop Wizard anymore because we don't actually use Drop Wizard, but it's using Juice still and Jersey on that side. And then on the other side, we have Spring Boot.
Yeah.
So Spring Boot flavor is the more popular flavor.
Sure.
I think it has about 60% of all the services, or maybe more now.
Sure.
It is the more popular flavor. And I know we're here to talk about Spring Boot. So what I can tell you in terms of the two different flavors is that when we go to implement a new feature, we still implement it in both flavors, but often the amount of code needed on the Spring side is far less.
Oh, good.
Spring gives us a lot more kind of out of the box than we get on the other side. So
that's cool. I loved. Drop Wizard obviously is Spring Boot wouldn't be here, but for the significant inspiration that Drop Wizard provided, right? And we had Coda Hell metrics. This is not for you, I'm sure you know this, but for the audience who may not know, we even had Coda Hell, the engineer who created Drop Wizard, and he created a metrics library which is Yammer metrics or Coda Hell metrics or whatever. It's been called a number of different things, and that was
Drop Wizard metrics.
But supported out of the box in Spring Boot 1.0, right? And then we created a library that we think supersedes that called Micrometer, but we used the great stuff when it's there, right? Drop Wizard metrics was awesome, so we used it in 1.0. Embedded style of building services, it's good. And Coda Hill himself has since admitted said had Spring Boot been there when he created it, he wouldn't have created it, right? So it's I think there's that's the highest compliment we could have been paid,
Yeah, I think that's great. I mean, when and we can talk about this maybe more a little bit later, but when I see like what Ktor is doing in the Kotlin space for web frameworks, right? And then I see what Sebastian in the Spring team is doing with some of the cool experimental projects he has. Like I see that the influence is there, right? Like people in new projects have the freedom to build stuff from scratch and have really great ideas, and then the Spring team can kind of absorb that and work that. And it takes a little longer, but absorb that into the Spring paradigm, which I like.
I love that. That's a great point. Actually, another one is Sebastian worked on this, and it's obviously and so did Arjen Poutsma on the Spring Web stuff tier, web stuff side. The functional reactive HTTP endpoint style, right? Which once if you've used Sinatra or Express.js, or if you've used Scalatra and the Scala community, or Spark Java, or there's just a dozen different projects that all had a functional predicate and then a lambda to respond, that style. Once you've used it, it feels kind of like that could work too. That could be just as nice as a component model for Spring. And so half a decade ago, we actually added that to Spring, and it's one of those things where it's just, that feels great. It feels really nice to have that there. And sometimes if I just need a few endpoints, I'll just do it that way. It's fine, So good point.
Yeah.
When you support Spring Boot, is there some sort of mandate from on high around which version of Spring Boot people must use, or what dependencies they must use, or what version of Java they must adhere to, or what does that sort of look like in terms of?
That looks a little different than it does in a lot of places because we don't do a mono repo. So we don't have direct control over these things at the platform team level. And so what it comes down to is certain things are required just because it's what's compatible with what we're doing. And then other things, though, are there's some discretion there. And that is mostly to give people time to upgrade things as they have the ability to. So, for example, right now, we officially support Java 8 and Java 11, although 90+% of our stuff is on Java 11, but we have those few stragglers that are still on 8, and that's still fully supported. And then we have a couple more leading edge services that are on 17 already, even though we don't officially support it, but they're kind of our early adopters and testing the water. And so once we feel confident that everything is good there, we're going to tell everyone that we suggest that they update to Java 17. And then we give a time frame under which to do it, a pretty generous time frame, and that way teams can plan when they're going to do that work, how much work is involved. Obviously, the A211 one, that was the hardest one. And then we have what some would call an IDP, internal developer dashboard. Wait, what's the I'm blanking on the acronym, but the internal developer portal, that's it, IDP, yes. But it's a dashboard that shows all of the information we collect on each service, things like your Java version, your Gradle version that you're on, the version of our Rue framework you're on, which maybe feature flags we have enabled or disabled. Like, for example, I'll give you an example of what that looks like. We have our configuration server, and First Cloud config did not exist in 2014 yet, right? So we wrote our own. It's not a big deal. It's a hash map as a service. It's like really not a big deal. So we have our own configuration server, and originally we were using REST to talk to it. Then we introduced a JSON RPC protocol, but now we have gRPC on it. So we want everyone to move to gRPC. So we are tracking who is on gRPC and who's not, who's still on the older protocols. So we track kind of all these things, and then there you can see the overall health of your service, like which migrations do you need to be working on, or are you falling behind? When are those things due? And then we can follow up and have accountability. If something's falling behind, we can follow up with the management team or whatever of that group to say, what's going on with the service? Like, there's not enough people to maintain it, or there's some other constraints. Like every once in a while, we even jump in to help. Like if there's just not enough people to get the work done, we'll just jump in and be like, okay, we'll do these migrations for you just to get you over the line. So
that is super valuable. So that it's you're not just you're not just barking, you're contributing. That's really cool. Okay,
yeah.
Good. Containers that you build, when you build the containers, is there any central recipe for that, or is that?
Yeah. So in the actual build tool chain that we have, so within the service platform team, we actually have a couple different verticals within there, and one of them is JVM stewardship, and that's my personal expertise. And so that goes into what is all the Java specific tooling that we have for our service platform, and part of that is the build tooling. So we have about a handful of custom Gradle plugins that we've authored that are kind of like mostly they're like convention plugins, in that they just kind of apply your standard plugins that you would want, like check style, PMD, things like that, and then just configure them with our standard like rule set or whatever. And then there's a few plugins that do like fully custom tasks, and there's stuff there. That's how we collect all this information for the portal, right? Is at build time we collect information, create a file, upload it to S3 somewhere, and then our system can suck that in. So we have standard way of building our services with a Gradle plugin, and it's using we're using the Docker daemon under the hood, but actually we have a new version of that now where we're using Jib, the Google project Jib, to build the OCI image. And one of the cool things about that is it's allowed us to easily target multiple platforms like AMD 64.
Nice, cool, very cool. Okay, so that is. And, okay, a couple things. So you're using Gradle. Is that like for all JVM projects? That's like already done?
Yes, everyone's using Gradle. That wasn't something we had to force people to do. It's just that's always been Gradle. We've always been a Gradle shop. We've been all Gradle since I remember when I joined. Everyone was still on Gradle 2 point something.
Right. Wow. Okay, cool. So you've built up expertise around that. Which is good, because when you can get people on the same page, you get inertia, and with inertia when you get consistency, you get inertia, right? With inertia, you get better results faster, Okay. Jib. So you're using 64 AMD, like you just mentioned ARM 64. Is that what I think I understood you said?
Yes, maybe I misspoke, but yeah, ARM 64. Yeah. So when we build our images, we build both the AMD 64 and the ARM 64. Or the x86 64. whatever, the regular
Yeah.
one and the ARM one. That helps us in a couple different places. It helps us with local development for people who do have the newer M1 Macs.
Right.
I personally use Linux, so that doesn't affect me, but we do have a lot of developers with those computers, and so they can natively run those images. And then it also helps us with the AWS Graviton instance type, the ability to deploy to ARM64, which
is amazing. Those things are fast and cheap. They're amazing. Oracle, what is it? Oracle Cloud, OCI, Oracle Cloud Infrastructure. They have Oracle Cloud. They have ARM support. You can tell who wants to win. But the people who are out there with ARM 64 support early, they knew something. That was.
We're still evaluating it and learning about it, but we have the ability to deploy it, and so that allows us to try it out. One thing I've noticed, for example, is the JVM by default allocates double the amount of memory per thread when it's running on ARM64, and I'm not sure why. Maybe there's probably a good reason for it, but I don't know what it is yet, so I'm still learning myself.
That would be a fun. I wonder what it looks like in the world of Loom when that arrives. Soon enough, as well.
Yeah, that probably mitigates that issue. But we do see that, they will use more memory. Especially services with a lot of threads. But because they're so much cheaper, you can just run more of them, and it's still a savings.
But yeah, exactly. Still ahead. It's crazy. I love ARM. I didn't know I was a fan until I got these goofy MacBook Pro M1s. Back in 2020 onward. They're just anyway. Whole other Oprah. We'll have another discussion some other day. Anyway, carry on. So JVM, some 8, mostly 11. You've got a Jib-based build with Gradle going to Kubernetes. I mean, already pretty standard stuff. What are people on their own at that point, or what about when it comes to actually handling things within the application proper, things like auditing and metrics and security and so on? Those are, let's say you're using Spring Boot. Those are things for which I think maybe an auto config might be appropriate, right? A starter.
Yes.
Do you have to understand that?
Yeah, so that's where what I mentioned before, Roo comes in. Roo basically is a library that contains, if we just remember, there's 2 flavors. Just keep that in the back of your head. But I'll just talk about the Spring one.
Okay.
I'll talk about it in Spring terms. It comes with a bunch of auto configurations that you get for free that will spin up various things. For example, micrometer, we use that. We don't. We actually disable the auto configuration Spring Boot provides because we wire up our own stuff because we want to do things a little bit custom, and we want it to match our and share the code between our other flavor, right? So that's a pattern you'll see a lot is, yes, this comes out of the box in Spring Boot, but we disable that because we have some shared code to make it the same across both of our flavors, and we want to use that shared code. Usually, I mean, sometimes it's a case-by-case basis. Sometimes it's just well, actually, the Spring Boot one's going to work just fine. Just let that run. Sometimes it's actually working differently there than it is on our other side, so let's disable that one and use our shared code. It's a case-by-case. For example, with Micrometer, we have some custom tags that we want to apply for all metrics that we're logging, we set that up for you just automatically with an auto configuration, and there's about 120 different modules in Brew, so it's highly modular, but it has a lot of different functionality. For example, the way we talk to Cassandra, we're not using Spring Boot Cassandra, we're using our own thing because the DataStax driver for Cassandra, when we started all of this back when it was still in 2.x and then later 3.x, did not do entity mapping for you. So we built something for doing entity mapping. So that is our own wrapper around it, and so we wire that up for you so that it's really easy for you to write your data access objects.
Nice. That's a win.
That's just a couple examples, but like I said, we have dozens of different features that we just wire up with all of the stuff that you need for our platform out of the box. Another quick example is gRPC. We're using gRPC, but it's going through the service mesh. So where do you talk to the service mesh, right? It's localhost some port, right, depending on how you have it set up. So we apply that configuration so that all of the when you you can inject in a gRPC client in your Spring Boot application, and when you do, it'll automatically come where it's hooked up to a managed channel that is pointing at the service mesh, so that the service mesh can handle the traffic for you.
That's neat. Okay, so you can actually develop most of it locally, and it just feels right at home. And that same local host centric code also works in production. You don't have this weird like, I tested it on my local machine, it's going to behave completely different over there. It's still just basically localhost, right?
Yeah, with the service mesh, yes. For the purposes of integration testing, things might be a bit different. Because you don't want to necessarily use that exact port when you're running your integration test. You might want to randomize the port. So you can still configure things to point them elsewhere for integration testing purposes and things like that. But there's just some kind of standard that we apply. Like another quick example, our databases are registered in Eureka. We use Eureka for discovery, Netflix Eureka. So instead of configuring the driver with the actual IP addresses for your contact points or host names for the contact points, instead we have some code that goes to Eureka, looks at, I know that I'm supposed to be on Cassandra cluster 1 or whatever, looks that name up in Eureka, gets the contact points from there, and passes that to the driver. So it's just this little bit of glue code that makes things seamless in our in our platform.
That's awesome. That's awesome. Okay, so are you using any of the Spring Cloud components? Like you just mentioned Eureka. Do you use that for service client-side load balancing and things like that with a discovery client?
So we used to use Spring Cloud Discovery, but actually with one of our recent big upgrade cycles, we actually dropped that dependency, but we're still using Spring Cloud Context. So we're running up our own discovery client because we're customizing it. Because we're using our service mesh to register your service in Eureka, we don't want the service also trying to register with Eureka. So we actually customized the Netflix Eureka client to not write to Eureka, but to read from Eureka only. So there's some customization we did there. So we wire it up, but we still use Spring Cloud Context. That core part of Spring Cloud that allows configurations to be updated at runtime is very, very cool. And we leverage that a lot.
We should talk offline. There's also, you can disable auto registration in Spring.
Is that feature out of the box now? Yeah. There's some other customizations too. So
it's good to know. Okay, that's really cool. I mean, it's just very cool that you're like able to make as much of this work for so large a use case, a large spread of services. Let me think about this. I don't even, and it's kind of interesting. You're using you're using Eureka for things like the Cassandra database, right? That's actually really cool. Normally, I just think about it from surface to surface communication, but yeah, why wouldn't you? It makes perfect sense for infrastructure as well, right?
Yeah. That was something we added later, but it's nice because it just like makes things more consistent about how we do things.
Awesome. And then you're using Java for most of the code. Is there any Kotlin?
Oh yeah, so about 5 years ago, being a big fan of Kotlin, like I said, I organized the Chicago Kotlin user group. I attempted to introduce Kotlin on the back end, and it didn't go so well. I think a lot of people were a bit skeptical. Maybe they had, I think a lot of them had gone through the whole Groovy thing, the Scala thing, and see this promise of, oh yeah, you can just write any JVM language, it doesn't matter, kind of not live up, right?
Right.
Both of those other languages have some significant issues with like Java interop or just learning curve. And so there's a lot of skepticism there, and it's still very early. Kotlin was getting popular in Android space, but on the back end, people weren't really using it yet. And so there was not a lot of appetite to be like the ones trying this out at that time.
Right.
So, but we did adopt Kotlin in Android around that time. And since then, that's like all of our Android stuff is Kotlin. And then we also, remember I mentioned those Gradle plugins. Those are all Kotlin now as well. That was an easy sell because they were groovy. And so Kotlin was an easy sell there. But also interest in Kotlin started picking up again amongst the various product teams. And at a platform team level, we said, well, it's just JVM. We don't care. I mean, obviously,
Right.
I personally cared, but as a team, we didn't care. Like, if you want to do it, fine, but no team really felt empowered enough to do it, right? Like on their own. What
Okay.
are we going to be the one team that's doing it? What happens if we lose some people and we need other developers and no one wants to help us because it's Kotlin? Or so there's a lot of concern there, and so they basically asked the platform teams to get involved in it a little bit more to just kind of help them talk through what we need to think about when we want to adopt this new language on our back end, even though all of the tooling is the same, right? Like our build tooling is the same and our deploy tooling is the same. What do we need to think about, right? And so I helped them with that. And so earlier this year, we did officially give full support to Kotlin on the back end. And we have, I think, 4 teams doing that now. We have some services in production already. Yeah, and it's been going really well so far. There was some work that we did have to do, actually. We want to get our static analysis in place. So
Right.
AT-lint and detect, those kinds of things, getting those put into our standard plugins by default with some work to do. And there were a couple other very minor things that, I did to smooth the path for some people, but it's been going very smoothly.
So, with those 4 teams, did they already have code on Java before, or in Java, the language that they moved over, or did they just greenfield new projects and do those in Kotlin, or what's
one of them? So 2 of them are starting new services. So they said, let's start it in Kotlin, and then the other 2 are working on conversion.
Okay, wow, conversion with a K. That's the
Well, so I don't think anyone is really trying to convert whole services to Kotlin, but
sure.
They are looking at converting, like just writing new code in Kotlin, or converting just some parts. Like, for example, with the Spring Boot app, right? All you have to do is convert your main application class, say like your top level application class, to Kotlin,
Right.
and you unlock the ability to use the Beans functional DSL, right, in Spring. And because that's a Kotlin only Spring feature. And so you just have to convert that one class to Kotlin to unlock that feature in Spring. And so that's worth it. That Beans DSL is very nice.
Yeah, I quite like it. For people who don't know, you technically can do this from Java, but it feels icky and it makes me sad. There's a DSL that's implemented as an extension function in Spring Framework 5 and later. And so basically, when you do a run application, passing the type of the main class, parenthesis, curly bracket, and then that actually is it's a lambda that you're passing in that's actually technically inside some parentheses, but it doesn't matter. And then in those parentheses, you can actually add an initializer because you have a pointer to the Spring application as this context, and you can call add initializers. And then instead of registering an application context initializer and all that, and using the inline object creation syntax in Kotlin, there's this nice DSL. You just say beans, curly bracket, and inside there you can say bean, curly bracket, and then register an object as a supplier. And it's just really, really nice. It just reads like what Apache HTTP config files kind of look like, sometimes, it's just.
Or KTOR.
Yeah.
I like to compare it to KTOR because it looks a lot like KTOR.
Oh, yeah. Just powerful stuff.
And I think one of the coolest things about it is the way that your dependencies, when you inject them, can just be ref. Like the function is just ref parentheses. Like you don't have to know the type, the name, or anything. So compared to doing like bean methods at configuration classes, you don't have to inject all the parameters in the method signature and then pass them into the constructor. You don't have to do any of that. You just ref for each parameter. Ref. It's very, very slick.
Now, for people who, again, we're doing a YouTube episode for people who are listening to this on a podcast. So for their reference, who don't quite know about Kotlin, it's possible in Kotlin to have a function that gets a pointer to the type that it's being assigned to. So, and you don't have to explicitly pass it in. So basically I can say I have a variable of type string or of customer service. I can say equals ref parenthesis, and that ref call will know that you're trying to assign it to a customer service in the function, and you can use that to say, hey, Spring, give me a bean of type customer service.class. It's called a pseudo reified generic in Kotlin, and it's just really, really powerful. But it has and but the compiler has to know to what it should assign the result of that value. So if it knows you're passing in if you're using ref in the call site for calling a function that has this parameter, an object of type t, then it knows that ref should be a t or a foo or a bar or whatever. But if you can do that, and you can a lot of places, then it's just really, really nice. Just ref parenthesis parenthesis ref parenthesis parenthesis. No more like context get bean. No more like foo space foo to inject it as a bean method provider parameter. It's just really elegant. But again, one of those things where if you're not using Kotlin, you don't even know what you're missing. It's just sad.
Yeah, and one of the things that makes me excited, so we could talk about now what makes me excited for the future of Spring is, we mentioned him before, Sebastian Deleuze, who has this Spring Foo project. And he started this project, I think it was like 4 or 5 years ago now, which is basically like taking inspiration from like the K-Tours of the world, or even like the Micronauts or whatever, these nice expressive configuration web frameworks. How can we bring that to Spring? I'm assuming was his thought process based on what he created. And what he did was he made it possible to spin up an entire Spring Boot application without having any auto configuration enabled at all.
Right.
And everything is done using these functional DSLs. And converting the existing auto configurations that are out there into application context initializers. And when you do that, it does a couple things. One, it allows you to create kind of like a Kotlin DSL or even a Java builder. Kotlin DSLs are really just a fancy Java builder pattern, right? And to configure your application, which makes it a lot more fluid of an API. For people who the Spring annotation-based stuff seems a little bit like automagical or hard to follow. It's a lot easier to follow because you can kind of like click through the code and follow what it's doing a little bit better. And so it gives you that expressiveness. And the other thing that it does is it gives you a lot of performance because there's no runtime reflection going on there. You get extremely fast startup speeds when you do that. I'm really happy that the routing DSL and the Beans DSL both made it into mainline Spring, but there's still a lot in his Spring Foo project that has not made it upstream yet, and I'm really hoping that it eventually does. And I'm also trying to contribute back to that project to make some improvements and make it a little bit maybe more production ready. So hopefully that we can get it one day.
So that project has been. Again, I suppose you must have seen the blog about a week ago where they referred to Sebastian as working tirelessly like a quote unquote Greek hero, which totally fits because he's a legend. I mean he's French, but they're talking about like classic Greek tragedy comedy heroes, that kind of thing. But anyway, that's problem. Part two is Spring Foo is awesome. You're right. It's a for those watching. Be aware it's experimental. There's no plans for it to go GA, unless there's like a overwhelming show of support for it. So, but we use it as a research bed from which to integrate great ideas in Spring and Spring Boot and so on. And as you mentioned, a lot of things started there and they migrated into the main line. And a huge part of that is they focus on performance, right? So it was if you look at the reflection and things like that, that informed a lot of what we did in Spring Boot 3's AOT engine. So there's actually an AOT engine that'll take, for example, your at configuration classes and turn them into functional configuration. And then that's what gets fed into the compiler. You don't need to do GraalVM to take advantage of that. That's reflection-free configuration. You just enable the AOT mode in Spring Boot 3, for example. And that'll now your Spring Boot application is basically as free of reflection as your average Spring Foo app. It's going to be a little bit slower because there's still some, but basically, that's huge. And then you're right. Those great DSLs that are all over the place in Spring Foo, and the Beans one, you mentioned that, the routers. I mean, it's just so many great things there. And of course, the other reason one of the big reasons that he was looking at Spring Foo was because there was no reflection, and that made it a great way to try and get an app working on GraalVM. But of course, now there's a much more natural way to do that, right? The AOT engine I just described. But again, that informed all that stuff. AOT, it informed our GraalVM support, and it informed the DSLs that you see popping up. Yeah, absolutely right.
The IoT part is important because it means you can take your Spring Boot app as is and run it on GraalVM, right? You don't have to
Yeah.
change anything. Spring Foo requires you to make some changes in your application. Yeah. So, I think one of the big exciting things going forward is if we can figure out a way to make it possible to use Spring Foo or like get that stuff into Spring so that, yeah, sure, for now we'll rely on those AOT conversions to make everything functional, but over time we can maybe refactor, gradually convert all of our stuff into the functional style. Then eventually you don't even need that step, and it will just work, right?
Right.
That's the hope.
I mean, that's what I'm saying. I think that we're going to get more and more of that. The Beams DSL is a part of that, right? You're absolutely right. That aesthetic, some people want it. It would be nice if there's more of that in Spring Boot itself. We're getting there slowly but surely. That project, wow. And then did you see all the cool stuff coming out of Kotlin Conf? Because you and I just talked for like a brief minute. I was in Chicago. I was lucky enough to co-present with my buddy Justin Riak at the Kotlin and Java's user group in Chicago, where you were just, I don't know.
Which was a great event, by the way.
Justin's amazing. But anyway, the event was good. But did you see the stuff the week before at Kotlin Conf?
I haven't caught up on it yet, honestly. I've been so busy. I was at DevNexus, and then that was just right before, and then yeah. So I was still catching up on stuff from being there, and then we had this event, and I know that they said that Kotlin is now the default language for Gradle.
Right.
That was one of the big ones that I saw, but I haven't gone back and caught up on everything yet.
The other thing that kind of blew my mind is like WebAssembly. We're not there yet.
Oh yeah.
It's not like it's not like you can take a JVM application and get it to work in WebAssembly, but the pieces are slowly but surely coming together. You can do.
Sebastian's working on that too, right?
I mean, he's done experiments. Yeah, he's done some work before. I won't speak for him, but he's got a really deep bench of knowledge around WebAssembly and all that stuff. And the technological pieces, we have garbage collection now support. There's a new way to do garbage collection in WebAssembly, right? And that was what was stopping it from being a suitable target for languages that have a runtime like Java and so on. So if you have that, technically it could be possible, to take JVM bytecode and get it moved over there. I'm not saying it's going to happen tomorrow or even this year, but it's possible now where it was just not even worth addressing before, It's just a matter of time, it seems to me. And I can't wait. You and I should have this conversation again in like a year or two and see where we are.
Yes.
The idea of running a Spring Boot app in WebAssembly is like my dream, It's just one of those, because you could run that in the server side, right? And now we're talking about, kilobytes maybe or whatever, maybe hundreds of kilobytes or whatever. I guess you call that megabytes, but not hundreds of megabytes,
Who knows? Maybe Project Panama helps with that as well. I don't know. We'll have to see how that shakes out.
Yeah, so much cool stuff. Okay, so I guess we covered a lot, but I feel like we could go on forever. What is the thing that you and your organization are looking forward to in the landscape? You just mentioned Spring Foo, but I mean organization wide, are there like horizons without disclosing anything we should know? What are some of the horizons logically that you're sort of mapping out?
So I think some of so my focus is on like JVM stuff specifically. So I'm going to have that bias, but I'll definitely say Graviton, running Graviton on EC2 is something that a lot of people are excited about. We have a lot of excitement over that. So I've already kind of done all the stuff that I need to do for that, like getting our images built for it and everything. So now I'm just kind of sitting back and watching people actually deploy it and do analysis on it and getting to see all of that stuff. So that's cool. Getting up to date on, so for me personally, I think the biggest thing for me is getting us to Java 21 when that drops so that we can leverage Loom. Because I think really, we have not done anything reactive, right? Pretty much. We have stuck with WebMVC. And so I think the Project Loom has a potential to be a game changer for us.
Yeah,
You know,
big time.
mostly what our services are doing is I/O, right? We're like waiting for a database call or waiting to make a gRPC call or something to another service. So I think the potential is there that this is going to be a big deal for the scalability of our services. Some of our bigger services that run dozens and dozens of nodes, like maybe we can cut those down a lot. So I'm excited about that. I'm excited about further Kotlin support. Like I mentioned the Spring Foo, but also like I'm working on what can we do within our own framework to have a DSL like API similar to Spring Foo, and kind of unlock that nicer developer experience for people who maybe aren't as familiar with Spring. That maybe they're coming into our organization not familiar with Spring, so they don't know what all these magic annotations do, and maybe this helps a little onboard people. So those are the kinds of some of the bigger things that I'm looking at, and also security. I'm looking a lot at our security posture with our services, with dependencies, open source dependencies, and our base images and things like that.
And it's getting. I mean, it seems like that's the next industry that's going to grow. Like, what does AWS but for security look like? The company that commoditizes security and makes it just there for everybody.
There are a bunch of companies right now angling to be that, right? So I'm keeping an eye on their products, what they're doing, and I'm just trying to keep up. We already have pretty good dependency scanning in place. We've had it for years, and so we're pretty good at that. But it could be better. The tooling could be better, and so we're working on that. And also, the experience for the developer could be better because we have these like false positives or like CVEs and open source libraries that are not getting updated. And what do you do about that? You're stuck, and so that's something kind of like we're dealing with on a day-to-day basis. But then also trying to think about long term, what is a better way to handle some of this stuff.
Right. That's awesome. I had a thing I was going to ask you, and it has left.
Oh, no.
Sure, it was nothing. Nothing. Something before. What were we talking about before security?
Talking about the DSLs.
DSLs.
I was talking about Loom.
Yeah. Loom seems like it was. I was gonna say, Loom. Yes. This is why I don't remember it. I do remember it now, but I remember why I don't remember it, which is it wasn't all that important. But what I was gonna say was it would be very cool if we could all normalize getting paid the delta in our cloud bills for every ounce of efficiency that we contribute to the production cloud footprint. Because I think like with Loom and GraalVM and AOT and all this kind of stuff, we JVM developers could be in for a huge payday if we could just get the company to be like, look, we're paying X, every penny you save, you can keep. Just come on.
Yes, yes.
Let's make
count me in on that platform. I'm there because it's coming. I really do think. I mean, the JVM is already, I think, underrated in terms of running services. Like amongst the greater technology community, there's still kind of a perception that Java is bloated or slow or whatever. And for long-lived service processes, that's just not the case. It performs extremely well. But I think what Loom is going to do is make JVM also have the best-in-class concurrency story, which I think right now it doesn't. Right now it's okay. It handles it okay. And the newer concurrency APIs that were added in was that 7 or 8 help a little.
Yeah.
And we have reactive, and that's fine. But we don't have like Go routines or like Kotlin coroutines are also great. And anyone doing Kotlin coroutines, or if you're thinking about it, yes, they are awesome. And I use them a lot in my Kotlin code. But having that built into the JVM itself and seamlessly usable from any library in Java is going to be a game changer for the ecosystem. And I think that I know the people who the people I talk to or the people I listen to that do conferences and these developer relations people and everything like that are all very excited about it. But when I talk to people who are just getting their job done, right? They're just your more traditional just developer doing their job. Most people, it's not on most people's radar, and I think it needs to be because I think it's underestimated how much of a big deal it's going to be.
Oh yeah, 100%, 100%. We did. I mean, I'm sure you saw this, but just for the people watching, the Spring team, we've done a number of blogs in the last 6 months talking about Loom and its intersection with, the stack. And there's a really great blog that came out by Mark Thomas. Gosh, I don't know, February, March, something like that, right? Wherein he talked about the potential gains for someone using Spring MVC on top of Apache Tomcat, which is, for those of you who don't know, what is happening every time you just add Spring Boot Starter Web to your Spring Boot app. You're running Spring MVC on top of Apache Tomcat. And basically, under Loom, those applications get the same scalability as your reactive stack, right? It's just free scale. I mean, this is why it's just such a terribly bad time to be still stuck in Java 8 because you're throwing money away. Just once you go from 8 to 9, it's easy, right? 9 to 21 will be a walk in the park. It's just 8 to 9, and even that, the holes have been spackled over by this point, And
I can speak to that personally because getting our framework to support Java 11 was a years-long process. We had so many dependencies that were not compatible, and we had to just do a ton of work to get things up to date. It took years, and from 11 to 17. On the Spring side, it was literally nothing. I just tried going to 17, and then it worked. And then on our other side, we did have to do some upgrades. We had to upgrade our Juice version a bit.
Same as yeah.
Very minor stuff. And that's from 11 all the way to 17. So it's getting over that hump to 11. That's the hard part.
Huge.
And I totally get that, but it's totally worth it because it's when you do it, you're not just unlocking 11, you're unlocking all the way up through Loom. You're getting records, you're getting Loom when that comes out.
Loom and records and multi-line strings. I don't know if people know this. We have multi-line strings now and var auto types. Oh yeah, this is
Kotlin has those. Kotlin's had those, but if you don't have Kotlin in your organization, then it's again, you don't know what you're missing.
John, you've been phenomenal. Did we miss anything? Anything we should know that you want to share before we get to the wrap up?
Well, I don't think so. I guess I'll just give a plug for my open source project that I'm working on, KT-Lint Gradle, the Gradle plugin for doing linting for Kotlin. It was first run by Jonathan Leishu, who still is involved in the project, but he has been doing talk about another Greek hero. He's been really doing a lot for open source security in the Java space. If you see a CVE in the Java ecosystem, 90% of chance he reported it and also fixed it. He's doing incredible work there. He's now with the Linux Foundation doing that, and before that he was under the Dan Kaminsky Fellowship, and so he just doesn't have the time for KT-Lint Gradle as much as he used to. So I've been working on that, and there it kind of lagged behind the KT-Lint. So for those of you who don't know, KT-Lint, the actual linter, is not created by JetBrains. Because JetBrains wants you using IntelliJ, right, to lint your code. Okay. So the actual command line linter KT-Lint is currently the steward for that is Pinterest, and the Gradle plugin itself is under Jonathan. Those are separate projects, and so for the time that he wasn't really working on it so much, we kind of fell behind KT-Lint, the KT-Lint project itself. And so I've been helping get it caught up to the newer versions of KT-Lint, and KT-Lint is gearing up for its 1.0 release. And so they've been doing a lot of breaking changes lately in preparation of that to get the API to the state they want it to be in for 1.0. And so the reason I'm plugging it is that I really could use people just if you're using KT-Lint Gradle, you can change the version of KT-Lint that's pulled in as a configuration value. You can say, go give me KT-Lint 0.47, 0.49. Please try that out and report the issues you find, because I'm trying to get it up to speed and ready, and so we could use help just for people trying it out and reporting potential issues, just so we know that if something's breaking or not working before we start bumping up the default version and things like that. So could use that help, just bug reports.
Yeah, participation is key to the open source ecosystem. What about you, my friend? Are you on the internet, and do you want to be found? And if so, where can people find you?
Sure. I think you put my social handles on there. Waking Rufus on Twitter, although I almost never go to Twitter these days. I do use Mastodon. I'm at Waking Rufus at bigshoulders.city, which is a Chicago themed instance. I've been on there since 2017, so I'm actually a pretty big fan. So you can catch me on there. I talk about tech and other stuff on there. Feel free to reach out to me on there, and if you have questions about any of the stuff I'm working on or talked about today.
Bigshoulders.city. What is it? Waking Rufus?
So yeah, you do at Waking Rufus at bigshoulders.city, because in Mastodon, if you take that address and paste it into the search, it'll directly find my account.
Okay, let's see. Go Big Shoulders.
Don't need to put it in the chat here.
Yeah, chat's good. I want to make sure we've recorded it so that people have posterity. I even had it in the YouTube description. If I thought I could load that up faster than you could type it, I would just do that. But computers are fast, and
I don't think I have the ability to comment on from this streaming thing you're doing.
Okay. Hold on. I'm gonna load my live stream during the live stream. What could go wrong? 1 second. Talk amongst yourselves. I'll give you a topic. Rhode Island is neither road nor an island. Okay, I'm back. I was able to open the live stream during the live stream, and
you cross the streams.
Right, there's a portal that opened up with the 7 horsemen of the apocalypse, but I think we're going to be okay.
There it is.
Here we go. There we are. Good. Hey, everybody. This is fun. I had fun. Thank you, John.
Well, thank you so much for having me, Josh. This is great.
My pleasure. Thank you for sharing all this cool stuff, and I can't wait to. Again, we have to catch up. Like 6 months or a year. We got to try this again.
Come to JConf Dev in Chicago. They're going to be having it again this year in September. So keep your eye out for that CFP.
There you go. That's a great one. That's a good point too. Go to that. Absolutely. All right. Thank you. We got some thank you guys from Frankie's, and we got a peace to everybody. From Khaled. So thank you, everybody. Have a great day.
Thank you to everyone listening for listening to me ramble.